So today I'll be asking you a lot of questions, so try and address them as we go. There's we are going to look at correlation and regression. Correlation and regression, guys. And I want you to know something when it comes to correlation and regression. And it is this. Correlation has got several synonyms you can use for it. Okay. For example, who can give me a synonym for correlation? Correlation. What word comes into your mind when we talk about correlation? Come on, raise your hand and tell me some synonym for correlation. Correlation, correlation, correlate, correlation, correlation.
Relation.
Yes, Vitus.
Relationship.
Relationship, that's good. What else? Correlation, correlation, correlation. Can be, Opele. Correlation, correlation. Association, association. Okay. Yes, Mohammed.
The link.
Link, very good. Link, correlation, link, nexus, connection. Okay. Michael.
Union.
Union. Okay. So correlation is about relationship. Now, there are so many relationships that are bound. Relationship in so many things. Okay. Correlation is about relationship between two variables. And what is interesting is that the relationship can be strong or can be weak. For example, what do you think is a relationship between a brother and a sister? Is it strong or weak? A brother and a sister. Is that strong or weak? Mohammed?
Strong.
Strong. Very good. What about cousins? Cousins, generally. Cousins. Is it strong or weak? Cousins. Strong or weak? Harrison. Is weak, generally.
Yeah, not too strong. Not too strong.
Correlation is also positive or negative. Positive or negative. For example, what do you think is a correlation between consumption and income? Is it positive or negative? Raise your hand. Consumption and income. Is it po or net? Is it po or negative? Emmanuel.
Positive.
Positive. What about price and quantity demanded? Is it positive or negative? Mohammed?
Positive.
Positive. Okay. That is wrong. Price and quantity demanded. Sandra?
Okay.
Prof, it's negative.
It's
So I
negative.
was referring to the consumption. Okay.
It's negative. So pay attention, guys. Pay attention. Seriously. Stop whatever you are doing there, because this is a compulsory question. So I will encourage you to pay attention. Now, if you look on the screen, the relationship you're seeing on your screen, is it positive or negative? The relationship you're seeing, is it positive or negative? Po or net? Po or net? Prince?
It's positive.
It's positive. And then, of course, the one you see now is negative. Now, a correlation can be measured numerically. Okay. Correlation is actually between -1 and +1. When it is 0, there is no relationship. When it is towards +1, it means the relationship is positive, and moving towards 1 makes it strong. Coming towards 0 makes it weak. Now, when it is negative, moving towards -1 is strong negative. Moving towards 0 is weak negative. But when you are looking at the strength of the correlation, you don't consider the negativity. You focus on the absolute value of the number. Even though, of course, you mentioned the negativity, you focus on the absolute value. And when the data is normally distributed, we use Pearson product moment correlation coefficient to measure. When the relationship, when the data is normal, when the data is skewed, you use the Spearman rank correlation coefficient. Now, I want you to tell me the things you see on your screen. Is a relationship positive or negative? Let's start with number 1. Is it positive or negative relationship between X and Y? The number 1. Is it positive or negative relationship? Number 1. The one I've numbered. Is it poor or net?
Prof, it's positive.
It's positive. Who is talking? Emmanuel. I called Emmanuel.
No, my name
Okay.
is Divine.
No, it's Emmanuel I called. The Divine, I didn't see your hand raised.
Oh, sorry.
Yes, Emma.
Positive.
It's positive.
Positive.
Okay. And then the one on number 2 here. What is a relationship? What is a relationship? What is a relationship? Number 2. Yes, Priscilla.
It's negative.
Negative. What about number 3? What about number 3? Who can tell us number 3? Raise your hand. Number 3. It's quadratic. I know you're thinking about it. Number 4. Number 4. It looks more towards the area of logistic. Okay. So these are the relationships. Remember, you see something like this in an exam, and you should be able to identify each one of them. Now, let's go to regression. So what is the difference between correlation and regression? Write this down. Correlation is about association. Regression is about causality. Write it down. Correlation is association. Regression is causality. So regression looks at the cause and effect. And there are different kinds of regression. A regression is actually establishing what is causing the relationship to happen the way it is happening. What is causing this thing to be negative? That's what regression. Regression is looking at the cause, not just that they are related. See, two people can be all traveling relatively, they are all traveling to Accra. They are related because they are going to Accra. But then one is not causing the other. What is driving one to go to Accra is different from what is driving the other to go to Accra. So they are related, but one is not causing the other. But a person can have a blood pressure, and what is causing that might be the person's weight. So we need to distinguish between regression and correlation. And there are different kinds of regression. One of the regression that you have is a simple regression. Another is multiple regression. And then there is also dummy variable regression. If you are taking notes, you're going to enjoy this course. Dummy variable regression. Now, what is that? What is all this? Let's start with a simple regression. A regression, I told you, has got variables. The first important variable is the one on the left, and it is called dependent variable. The one on the right here is called what? Who can tell us? The X on the right is called what? If the Y is dependent variable, the X is what? Joyce.
Population dependent variable.
Okay. Now, what is another name for the dependent variable? Who can tell us another name for the dependent variable? The dependent variable is a variable that is being influenced. The dependent variable is the one being influenced. The independent variable is the one influencing. So the independent variable is the causal factor. And the dependent variable is a recipient. Therefore, the independent variable is also called explanatory variable. Write it down. And the dependent variable is also called explained variable. The independent variable is also called predictor or feature. And the dependent variable is also called response or outcome. So you can see that I've spoken about the dependent and independent variable. But what did we say about the independent? We said that this explanatory variable or the predictor or the regressor is also called regressor. It is a one that is influencing the dependent variable. But the question is, by how much? By how much does each independent variable affect the dependent variable. This is measured by the beta parameter. So the beta parameter, write it down, tells you by how much the regressor affects the regressand. It tells you by how much the independent variable affects the dependent variable. It tells you the percentage or the weight, the importance of that independent. So if the beta is 0, it means that that independent variable does not affect the dependent variable. So when you go to the multiple regression, you will notice that there are several independent variables, each one containing their own beta parameters. The beta parameter, when you have estimated it and it has become a number, it is now called coefficient. Write it down. The beta parameter, when you've estimated it and it's now a number, it is known as coefficient. So now, there's one more thing we haven't spoken about. As for the intercept, it has no implicit economic meaning for now, so ignore it, the intercept. But there is one particularly important variable in the simple or multiple regression we haven't spoken about. Who can see that? Tell us. Who can see that? Prince.
Doc, is it a U_I?
Correct. What is the name? If you check past questions, I always ask, what are the different names of the U_I? There are 7 different names of it. And I ask you all the time to tell me in an exam. Who can tell me the name of this UI before we know what it is doing? You see, there are several independent variables affecting the dependent variable. Several affecting the dependent variable. Several affecting the dependent variable. Several affecting the dependent variable. But then there are other factors that can affect the dependent variable we haven't mentioned. We go all the way to X5, but maybe there are X6, X7, X18, several of them. The UI captures all these other factors that could also influence the dependent variable, but have not been captured yet. What is the name of the UI? Raise your hand and tell me one of the names of the UI. What is the name of the UI? Vitus.
Is it the residual?
The residual. That's one good name. What else? What other name do you know of the UI? What other name? Yes, Harrison.
The error term.
The error term. Very good. What other name do you know of it? Write them down. Write them down. You see it somewhere. So you have the residual, you have the error term, you have the random noise, you have the disturbance term, you have the idiosyncratic error. Idiosyncratic error. You have the unobserved heterogeneity. Unobserved heterogeneity. Some people even call it white noise and so forth. You should know 7 of them. You see someone. So those are what we call the error term. The error term captures other factors that could also affect the dependent variable, but have not been captured yet. The general way of writing the whole thing is what you see down here, where each xj is representing the x1, x2, and on and on. So understand clearly the model. What is a model? A model is a representation of reality. Okay. So you should be able to now understand a regression model. Now, sometimes the regression model that we just gave you is a linear regression model, by the way. What you see is linear. Linear means that there are no squares. So when you come to this axis, there's no x raised to the power 2. There is no x raised to the power 2. There is no x raised to the power 2 or x raised to the power 3. Okay, so they are linear. When they are non-linear, Then you have squares. And when they are nonlinear, then we are now dealing with quadratic or polynomials. So when you have quadratic or polynomials, that is when you see that some of them will have squares or cube. They are nonlinear. And then we have a situation where the dependent variable is not number like this one here. You see, the yi is a number. But when it is a category, a label, a binary, then we are no longer dealing with multiple regression, but we are dealing with a logistic regression. So find the difference between a logistic regression and a multiple regression. Know it. Please know it. Please know it. Please know it. I beg, write it down. So logistic regression has got a binary dependent variable, or sometimes the dependent variable is even more than a binary. It has multi-class classification label. So the dependent variable is not just male and female. For example, the dependent variable can be the probability of getting a disease or not getting a disease. The probability of getting a disease or not getting a disease. So that makes it binary. Okay. Now let's take a real life example of a model. Okay. And you're going to answer some things for me. This is a wage. We all know that the wage of a person is dependent on the education. It's also dependent on the experience. It is also dependent on the position. And it's dependent on the ability. The ability of the person. Now pay attention. There are other factors that can affect your salary but have not been captured here. Raise your hand. Tell me which other factors that are inside the error term that can also affect this but have not been captured yet. Which other factors? Prince.
Doc, the industry.
Good. The type of industry can affect your wage. Very good. What else? Bex.
The location.
Location can affect your wage. That is true. Guys, I'm giving marks for those that are talking, just to let you know. That's why I'm doing a recording seriously for this. So if you know it and you sit down, it's to your disadvantage. Sandra.
Your negotiation skills.
Well, that will be part of that experience thing or your ability. Lord.
Prof, the profitability of the company.
Everything here is already part of profitability. Fully. I determine what is right. Don't worry.
I think over time.
Overtime is fantastic answer. Overtime. Overtime. Emmanuel. Emmanuel.
Prof, job role.
What?
Job role. The role that you play.
Position. That is in your position. Okay, so that's fine. You got the idea. Let's go to the next one. The blood pressure of a person is affected by the age of the person, the weight, the stress, the exercise, the smoking status, and the BMI. But of course, the other factors that can affect the blood pressure of a person, nobody should mention broken heart. Which other factors which are inside the error term but have not been captured yet? Labi.
Family history.
Excellent. Genetics. Very good. McDonald. McDonald.
Yes, sir. I was about to mention heredity.
Okay, no problem. So he said, Justin.
Diet.
Diet. Very good. Diet. Somebody has said it. Nathan.
In fact, I was coming to mention the diet.
Okay, that's what I said there. But there's one more.
Yeah.
Diseases. Other diseases can also affect blood pressure. What else? Harrison.
Yeah, sleep.
Sleep. No, sleep technically doesn't really do anything. Blood pressure. Let's go to Emmanuel.
Doc, certain medications.
Good. Certain medication. They are all part of the alcohol. Certain medications. They are all exactly the same. Now, Bex, last one.
Some life situations.
Everything is a family life situation. All right. So let's go to another thing. The quantity demanded of a product is affected by the price of the product, the complement price, the income, whether the good is a substitute or a complement, the advert, whether the good is a complement, population. Nobody should mention taste and preferences. What other factors can affect the quantity demanded that have not been captured, but they are inside this error term? They are inside the error term. In Chifo. Anita.
So exchange rate.
Exchange rate. Very good. Nathan.
The preference.
I said nobody should mention taste and preference. Emmanuel Asari.
Oh.
Eunice.
Okay, so I'm about to say the taste and preference, but I don't know if prestige or also.
No.
Inflation.
Eunice.
Inflation.
Inflation. That is expected price. Felix.
Employment and unemployment.
No. Anita.
So GDP.
No. Guys, stop mentioning all the macroeconomic factors, okay? Stop mentioning them. GDP, interest rate, exchange rate, all of those ones. Let's go deep dive. Lord, you still have something?
Yeah. Doc, Prince here. If Lord is not available, I was thinking the seasonality or the weather.
Excellent. That's what I was looking for. Seasonality or weather can also affect demand. Very good. Let's go to the last bullet here. In this last bullet, you can see that you have the wage equation, but then the first bullet is a wage model. Write this down. What is the difference between a specified regression model? And this is an exam question. That's what I'm giving you two right now. What's the difference between a specified regression model and an estimated regression equation? What is the difference between a specified regression model and an estimated regression equation? So, the first bullet that you see about wage is a specified regression model. The last bullet about wage is an estimated regression equation. There are two main differences. Who can raise a hand and tell me one main clear difference between the two? Between the specified regression model, watch my mouth, and the estimated regression equation. There are two main differences even as they stand. Who can tell us? Yes, fully.
I think the estimated one doesn't have the error 10, while the specified has.
Excellent. First, great observation. Second observation. Second observation is right there. Eunice.
So I read the figures.
Man, they don't ask me a question, no. You are giving me an answer.
The figures.
Anita Fianco. Anita Fianco.
Sir, please, the difference is the latter one has the coefficient.
Mention the name of that latter one. I was very specific in mentioning the name and I told you to write them down. Harrison.
Yeah, the estimated has got numbers, but the other one, which is the
Felix Jones.
it has,
See, when you don't write, remember the last time I said that the best way of learning is writing. Felix.
yeah, so that
The estimated has a constance of 150.
No, yours is wrong. I think the one who was talking before, he was just not using the right names. Justine.
The estimated one has the beta and the specified one
No,
has the
that's wrong.
beta.
The estimated do not have betas.
Okay, then it's the other way around.
Anita Fianco. Next time we tell you to write.
So the estimated one has the figures, and then the specified regression has the letters. That is the beta.
All right, okay. Well, you get it in an exam again, so take notes. Now let's go to the assumptions of regression and write them as I mentioned them. What are assumptions? Assumptions are certain things that must be in place for certain things to work. That's assumption. Certain things that must be in place for certain things to work. So for regression to work, we got to make an assumption. Certain things must be in place. The first is called linearity. That is, there must be a linear relationship between the dependent and the independent variable. The relationship must not be polynomial, nonlinear, but linear. You want that to be there. That's an assumption. For example, you say that before the University of Ghana starts working, lectures must be in place. I mean, the lecturers must be there and students must be there. If there are no lecturers and students, there is no university. Okay. The next thing is normality. The errors must be normally distributed. The errors we spoke about. The errors must be normally distributed with a zero mean and a constant variance. The errors must be normally distributed with a zero mean and a constant variance. That is the one you are seeing it as normality and homoscedasticity. Okay. Normality and homoscedasticity. Okay. So take note. If you check past questions, you also see that assumptions of regression are necessary. There is another assumption. And normally I expect questions, okay, because it's questions from you that shows me that you are following. Because there are some things on your screen that you don't understand, but you don't ask questions on them. The third assumption, the fourth assumption is that there must be no autocorrelation. There must be no autocorrelation. What is autocorrelation? Oh, by the way, when we say autocorrelation, we are talking about for the errors. So there must be no autocorrelation of the errors. There must be no autocorrelation of the errors. What does that mean? In other words, the error from one observation should not depend on the error on another observation. So the covariance between the two errors must not be zero. Okay. The covariance, it must be zero actually. It must be zero. The covariance of the errors must be unrelated to each other. They must be unrelated to each other. Then there is another assumption, which is multicollinearity. Write this down. I'm defining multicollinearity for you before we continue. What is multicollinearity? Multicollinearity exists when two independent variables are so highly correlated that multicollinearity exists when two independent variables are so highly correlated that it becomes hard to separate their partial effect. It becomes hard to separate their partial effect on the dependent variable. That is what we mean by Multicollinearity. So it's like the two variables are highly correlated. That's what it means. Multicollinearity, we'll practically look at that today. The two variables are highly correlated. In other words, they depend on each other. And you don't want that. You don't want two independent variables to depend on each other. Yes, Mohammed.
Doc, please, can you take that again?
Multicollinearity exists when two independent variables are so highly correlated that it becomes hard to separate their partial effect on the dependent variable.
Thank you.
It becomes hard to separate their partial effect on the dependent variable. All right. Yes, fully.
Doc, can you please throw more light on the partial effect?
Okay. So let's say that you have a variable called x1. Let's say, in fact, let me use practical thing. You have a variable called experience, and you have another variable called education. Okay. And then you are in a company. The company says that if you have 5 years experience, they will send you a full scholarship to go and do your master's. And after that, they will double your salary. So you are in the company, you have 3 years. The moment you got to 5 years, they now send you to go and do your master's. After your master's, they doubled your salary. Question is that what led to the increase in your salary? Was it the experience or the education? What will you say?
Yeah, difficult to tell.
Sorry?
Both.
I'm saying it will be difficult. I mean, maybe both.
Both.
That word both is what we don't want. So partial effect means you want which one is individually affecting the education, the wage. You don't want a situation where you say both of them are affecting the wage at the same time. Okay. Both of them are affecting the wage, not independently. They are affecting the wage together. Because without the education, you will not get the salary, isn't it? Even if you have the 5 years experience, without the education, you wouldn't have gotten the salary. And the salary increase. And also, you cannot also get the 5 years, the education, unless you have also had 5 years experience. So the two are intertwined. They are kind of correlated, highly multicollinear. That's what it means. So you can't separate their individual effects. Partial here means individual effect. But they are two intertwined. Does that make sense now?
Yes.
Okay. So that is it. That's the meaning of multicollinearity. And you don't want multicollinearity in a regression. Okay. Another thing you should note is dummy variable. Dummy variable. What is a dummy? A dummy is something that is static. A dummy is something that is not moving, stagnant, static. Okay. It's not dynamic. And there are some variables, some of the independent variables that are dummy. For example, you want to check, if you go and look at the ones we did here. Suppose you are looking at the wage. You say education. Education is in numbers. Experience is years in numbers. Position, position is a dummy. Because the position of a person can be executive officer, CEO, manager, supervisor, and lower level. So when the independent variable is not a number, okay, you remember nominal, ordinal, interval ratio. When it is not any of them, but it is rather nominal, okay, when it is nominal or ordinal, that is when we say it is categorical. And the way you treat categorical variables in a regression is very, very important. You create a dummy. So let's say that you are trying to determine pregnancy. And then one of the factors that determine pregnancy is gender. Gender is categorical, isn't it? Because there are two levels under gender. What is the first level under gender? Who can tell us? What is the first level under gender? What is the first level under gender? Is female, and the second level is male. Okay. So gender becomes a dummy. Gender is a dummy because inside it is either 0 or 1. That's it. Inside it is 0 and 1. So a dummy variable is a variable that can be coded as 0 or 1 or 2 or things like that. And there are levels for each dummy. And here is a rule. The number of levels are always one more than the number of dummies. Write it down. The number of levels are one more than the number of dummies. Which means that the number of dummies are one less than the number of levels. Write it down. I'm coming to ask you something. The number of levels are always one more. So let me ask you, if the levels are 7, how many dummies do we have? If the levels are 7, how many dummies do we have?
14.
Lord.
Prof. 6.
6, correct. Okay. You see, that's why it's wrong to answer when you haven't been called. You go and make a mistake and then you affect everybody. If you had raised your hand. So the number of levels are 7, then the number of dummies are 6. If the number of dummies are 4, how many levels are we talking about? Justine.
5.
5. And if the number of levels are 17, how many dummies are we talking about, Mike?
16.
16. Good. So keep that in mind. It's a very, very important thing for you to understand going forward. So dummy variables, we shall look at them very well. Okay. Dummy variables. Okay. The way you interpret a dummy variable is not the same way you interpret a numerical variable. For example, here you have return on asset of a company, which depends on the profit of the company, the type of the company, and the assets of the company. Now, looking at this, which of the variables are numerical? Which of the independent variables are numerical here? There are 3 independent variables affecting the return on assets. Which of them are numerical? Felix.
Profit and assets.
Profit and asset, correct. So the type of a company is a dummy. And this type is coded as 1 if the firm is a domestic firm, or 0 if the firm is a foreign firm. Okay. How do you interpret the profit coefficient, which is 20? You normally will say that on average, given the type of the firm and asset, 1 unit increase in the profit of the firm increases return on assets by 20 units. I say increases because the 20 is positive. That's how you interpret it. If you want to interpret assets, you say that holding the profit and the type of company constant, on average, a 1 unit increase in assets increases return on asset by 5 units. You see, I use the word increase. But then type of a company doesn't increase. Okay, you are either a domestic or foreign. So how do you interpret that? You say that given the profit and asset, the return on asset is expected to be 30 units more if the type of the firm is domestic. That is, if the firm is domestic than foreign. The return on asset is expected to be 30 units more if the firm is domestic than foreign, which means that the return on asset is expected to be 30 units less if the firm is foreign than domestic. So the way you interpret a dummy variable, you should not use increase and decrease for it, because you don't increase to become a male, neither do you decrease to become a female. You don't increase to become a foreign company, neither do you decrease to become a domestic company. So your interpretations are very important. We'll look deeply at that as we go further. For now, we want to look at a data set. A data set that I posted on the page the last time, known as Burukutu data set. Do you all remember that? I posted this on the page the last time. Burukutu data set. Do you all remember the Burukutu data set?
Yes, please.
Very good. Please open your R Studio and open that Burukutu data set in Excel. Open your R Studio and then open your Burukutu data set in Excel. You know what somebody says? Hey, cause we in. And the answer is yes. Nobody forced you to register it. Nobody. You did it out of your own volition. You wanted to do it and you did it. And you are doing it. And you are happy you're doing it. So keep on keeping on. Keep on keeping on. Let me open my Burukutu data sets for you. So on my screen is a Burukutu data set. There are two aspects of the data set. Okay. This is a data set. One at the Excel sheet at the bottom. One is called Burukutu data. The other is called Burukutu coded. One is Burukutu data. The other is Burukutu coded. Okay. I am going to work with this data with you. So if you have opened yours, raise your hand. And open the Burukutu coded, the sheet called Burukutu coded. Raise your hand if you have opened it. It's practical work we are doing. I'm going to be giving marks, so be following. Okay. Now, we are going to do a couple of things. You should be able to learn how to generate descriptive statistics for yourself. I'm not going to delay on that. So please, that one, you should watch the video back and then know how to do yourself, because I'm going to be moving fast. But because that one, I expect you to be able to do it yourself. But there's one more thing I want to mention before we start. Now, you at the top, you should click on Data tab. Data tab at the top. You should click on Data tab. It's somewhere here. Data tab. When you click on Data tab, on the far right, you should see Data Analysis. Please lower your hands. On the far right, you should see Data Analysis. If you don't see Data Analysis, let me know. If you don't see Data Analysis like mine is showing here, let me know. Anita, you don't see?
Sir, please, I see data validation.
Did you click on Data tab at the top?
Yes, please.
You should see Data Analysis. And by the way, I'm talking about those with Windows. So that means you all have Data Analysis. Are you using Windows, Anita?
Yes, please.
Okay, so on the far left, click on File. All of you don't see data analysis. Click on File. I'm going fast, so be hurry. Click on File. At the bottom, choose Options. At the bottom, choose Options here. A pop-up will show. A pop-up will show. In the pop-up, you will notice there are some tabs on the far left. Click on Add-ins. 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 And on the right, you will see Analysis 2-pack. I'm not talking about Analysis 2-pack VBA. You will see Analysis 2-pack. Click on Analysis 2-pack, just as I've clicked on mine. And then when you come down at the bottom of your pop-up, you see Manage and you see Go. You see Manage and you see Go. Click on Manage. Click on Go. Click on Go. And when you click on Go, a pop-up will show. Okay. A pop-up is going to show. In that pop-up, you see some boxes. One of the boxes is Analysis 2-pack. Tick that box like mine is ticked here. Tick the box. Tick the box for Analysis 2-pack. And click OK. And now when you go to the Data tab, you should see Analysis, the Data Analysis. Confirm if you can see it now.
Yes, please. I can see it now. Thank you.
Very good. Very, very, very good. So now, everybody click on the data analysis, and I'm using the coded though. Remember, I'm using the coded. I'm going to move fast this time. Click on the data analysis and choose descriptive statistics. Double click to choose descriptive statistics. After you selected descriptive statistics, you see the cursor is blinking in the input range. The cursor is blinking in the input range. Whilst it's blinking, highlight the kill in the data set, drag it all the way to RM, and drag all the way down to the end of the writing. Drag it all the way down to the end, like you see in mine. Drag it all the way to the end. Once you are done, check the labels in the box. You see labels in first row. Check it. And then where you see new worksheet, type sum for summary statistics, SUMM. Type sum. And then when you come down, check the box that says summary statistics. Check the box. And then click OK. A new sheet to be created, which is called sum, like this. And you will see that that new sheet will have all the summary statistics. They are repeated. The headings are repeated because if you check, by the way, whilst the thing is showing, click on the Home tab and convert it to 2 decimal place. How do you do that? Click on the Home tab, and then under the Help, you see General. Click on the General and select Number, and everything will be in 2 decimal places. Okay. You can arrange this thing. For example, you can highlight all of this, cut it, move it to the next cell. Okay. And then you can click and hold your control key. Click the headings, mean, standard deviation, hold down the control key and keep clicking. Whilst you are holding the control key, keep clicking, because they are all repetition. They are all having mean, standard deviation, blah, blah, blah. You want to just delete some of them. You want to delete some of them. You want to delete some of them. And then you right click on one, the last one, for example, kill. Right click on it and click delete. Everything will be deleted. And now you have a beautiful summary statistics of the entire data. If you are not able to do it, don't worry. You can watch the video and do that. So you should be able to generate descriptive statistics using your summary, your coded. Everything I'm using the coded. Next, you are going to generate correlation matrix. So click on the data tab again. Oops. Click on the data tab again and then choose data analysis again. Instead of descriptive statistics, this time double click on correlation. Correlation. A pop-up will show again. Inside the input range again, you're going to highlight everything like you did before. Click drag to the RM, drag all the way down to the end, and then check the labels in the first row. Check it, tick it, check it, tick it, check it, tick it, check it, tick it. And then under the new worksheet, name it as CORR, core, CORR for correlation. And click OK or enter. It will create another new sheet called correlation. Again, this is in many, many decimals. So click at the top left to the home tab. Below the help, click general and select number again. And everything now is in 2 decimal places. Everything is in 2 decimal places. So what you are seeing here is called a correlation matrix. I'm going to go to the PowerPoint and then we'll address some questions about the correlation matrix. First, let's try to understand this Brukutu data set. So you are writing a journal paper, okay? You are writing a long essay. You are writing a dissertation. The title of your dissertation, and all of you will do it. You do this. You all write a long essay or dissertation. The title is Determinants of Demand in the Alcoholic Beverage Industry in Ghana. Impact of location, occupation, and religion. So watch some of the variables. Location is a variable, occupation is a variable, religion is a variable. You may have done some introduction, literature review. I'm sure you were given some assignment by Dr. Freeman, weren't you? You were given some assignment, weren't you?
Yes, please.
Well,
Yeah, sure.
he told you to write proposal and things, right?
Yes.
Yeah.
So you would have made some arguments about previous studies on the subject, and you would have said that, oh, the previous studies didn't consider the effect of location and occupation. You justify it with references. You may even argue that few studies have considered religion, but they have not included Buddhist to the best of your knowledge. Okay. You may have identified other gaps. For example, most studies use ANOVA. They don't use regression. They use correlation. They don't use regression, and so many things. So this is your data set. Now, from the gaps, you would have stated your contribution, your objectives, your research questions. You normally would have critically reviewed the theoretical and empirical literature. You may even develop a conceptual framework from the theories you have gathered. And then you have to now collect data to answer your research questions or your research hypothesis. Now, let's assume that the data you collected is Brukutu Ventures, the data we are using now. Now, Brukutu Ventures actually is a local gin distillery concerned about the demand for the gin bitters. Why are they concerned? Because demand has been, in most of the retail shop, has been hard hit by the competition coming from the new entrants into the market. And management is worried, and they want to determine which of the predictors they have to focus on in order to better explain the quantity demanded of gin bitters. One of the predictors they have identified is price of gin. That is a P here. They also know that another independent variable is the price of the complement of gin. Gin is akbetish, more or less. A complement of gin could be Coke or kebab or something else. They have also identified that the average income of the people can affect the demand, the quantity demanded of gin bitters. So these are some of the. So this is the quantity demanded of gin bitters. This is a price of gin. C is a complement price of gin. Income is the average income of the people. Now, the other 3 variables, these are their levels, these are their dummies, and these are their dummies when you are taking it to the R studio. We will not look at this for now. We'll come to that later. So this is the one we used, okay, the dummies. You should be able to create dummies. Write it somewhere that learn how to create dummies. Learn how to create dams. Okay. Anyway, I'm not interested in that, but this is the data in Excel. So this is a feel of your data. Apart from the price, the complement price and income, the location, occupation, and religion can also affect demand. Okay. The location is two kinds of location. Whether the shop, okay, the shop that sells the quantity demanded of gym bitters is located in an urban or rural area. If it is urban, is 1. If it's rural, is 0. That is why when you come here, anything urban is 1, anything rural is 0. Another factor is occupation. There are 3 kinds of occupation: teaching, trading, and fishing. So if the people are teachers, traders, and fishers, that can affect whether they will demand the gym. Now, which of these groups do you think will demand a lot of akpeteshi? Is it teachers, fishers, or traders?
Teachers.
You sure? Are you sure?
Fishes.
Fishes. Those fishing.
Yeah, fishers. Very good. Yeah, it's possible. Now, when you go to religion, which of them religions do you think is likely to be heavy consumers of akpeteshi?
Christians.
And which of them? My dear, it's like you are doing lotto. Did you know any Buddhists who consume more akpeteshi than Christians? It's like you are mentioning the answers, some of them. You are doing lotto. I think you were the same person who said teachers.
I was just pulling their legs, but I know it's those who fish.
Yeah, but why will you pull their legs and the teachers and you come and pull their legs also for Buddhists?
I was provoking the teachers.
Okay. So the people who consume the less of akpeteshi are the Muslims. And then the Christians consume the most. And then the Buddhists will be in the middle. Now, all of them have been coded here. Okay. Now, let's go to the data. We'll come to the R, how to do the thing in R. But these blue things are things you should copy. So, we have generated descriptive statistics, okay? And we have also generated correlation metrics here, as you can see. There are some questions you'll be asked on the correlation metrics. So I want us to address those questions before we continue. First question, under correlation. You all have the correlation matrix in Excel, and I brought it here as well. Okay, so the first question under the correlation is following. The first one is, let me just go back and then ask you directly. If you look at the correlation, if I were to ask you that, tell me the correlation coefficient between price and religion Muslim, or let's say, yeah, price and religion Muslim, what would you say? What is the coefficient between price and religion Muslim? Who can raise a hand and tell us? What is the value of the correlation coefficient? Fully.
The coefficient is 0.47 positive.
Very good. So that is the one here. Those of you could not see. Okay. If you look here and then you start coming here, you will say that there's nothing, but then everything on the nothing is also a reflection here. What is the correlation coefficient between income and location urban? And when I say location urban, this is location urban. Income and location urban. Income is M, location urban is LU. What is the correlation coefficient there? Income and location urban. Lord.
Prof is 1.0.
Wrong. Income and location urban. Emmanuel.
Prof, it's 0.18 positive.
That is correct. So this is it. See, the reason why I'm asking you is I know some of you will get wrong like it's already happening. You should be able to easily identify the coefficient. Now let's go to the deeper part. Now, which pairs of variables are perfectly correlated? Which pairs of variables are perfectly correlated? What does that mean? It means I want you to tell me the pairs of variables that have a correlation coefficient of 1. Those are called perfect correlation. Nathan, give me the first pair. When I say
That's
pair,
price.
when I say
The
pair,
P.
I mean something and something.
P and P and P.
P and P. Okay.
Yeah.
And then you mentioned the coefficient of 1. Which other pair, Jennifer?
Yes.
Location urban and location urban.
Correct. Very good.
One.
Very good. Felix, what is another pair? Joyce,
OTR,
what is another pair?
OTR
Joyce.
1.0. Hello, Doc.
Yes, Joyce.
Q and Q with a coefficient of 1.
Very good. Guys, be very ready. When you raise your hand, be very ready to quickly unmute and talk, okay? We have a lot to cover. All right, now let's go to this question here. I want you to tell me 2 pairs of variables that are strongly correlated with the response variable. 2 pairs of variables that are strongly correlated with the response variable. By the way, which variable is the response variable here? Which variable is a response variable? When you look at it here, which variable would you say is the response variable? It's quantity demanded. Quantity demanded is a main independent variable, and it is a response variable. So the question now is, which variable is strongly correlated with quantity demanded? 2 pairs. So give me the first pair and then give me the second pair. Which pairs of variables are strongly, so when I say strongly correlated, you remember when we said strong, fully.
The first should be the coefficient of, P and Q of negative 0.87.
That is correct. So the first pair is this one, okay? It is the one that has the highest correlation coefficient with the response variable, which is Q, which is the second pair. That's the first pair. Which is the second pair, Esther? Priscilla.
So the second would be C and Q with a coefficient of 0.72.
That is wrong. Let's go to the second pair again. Eunice.
0.74, P and C.
That is wrong. Let's go to the second pair. Genevieve.
UTR, that's negative 0.78.
Please mention the thing well, You see, I said it's a pair. So you mention something and something. You don't just mention one thing.
And quantity.
Please
Sorry,
mention it.
and
Start again,
the
start again, start
quantity,
again,
which
start
is-
again. Pay attention.
Okay. So is the quantity and then 7.8.
Emmanuel Otenyagbeko.
So, Prof, it is quantity and OTR, which is negative 0.78.
Very good. This is how I want you to mention it. Okay. Very important. How you treat the thing is how you get a mark as well. Okay. So those are the 2 pairs that you're supposed to identify. Now, which 2 pairs of variables are least correlated with the response variable? least correlated, 2 pairs. Who can give me the first pair that is least correlated with the response variable? Henry.
So it's OT and Q of negative 0.11.
That is correct. I like the way you've put all together. Next one. And that comes first, by the way. So it's good you mentioned. See, if you don't know what is going on, you should be writing it. Okay, if you don't know, you should just be writing it. You also should write. That's how you learn. Okay, let's go to Prince.
Yes, Doc. So the next will be M and Q with a coefficient of positive 0.61.
Perfect. So you should know variables that are least and variables that are strong. Now let's go to the next question. This question will have 7 questions in the exam, so that's what we are going to. Next one is identify 3 pairs of variables that are mostly multicollinear. 2 pairs of variables that are mostly multicollinear. Now, what is a multicollinear variable? Multicollinear variables are independent variables. So anything in the dependent variable column is not part. They both must be independent variables. Now, let's look for the most highly multicollinear pair, the strong multicollinear pair. So let's go to the thing. Can you identify the first most multicollinear pair? The first most multicollinear pair. The highest. Kingsley.
Prof, I had a question, but I think I've had a solution to it. Thank you.
Okay. So when you're looking at the most multicollinear, you don't have to look at this section because that section contains scale. So that is out. So you have to look at the rest. Multicollinear. And the perfect collinear are not part. The 1, 1, 1, 1 are not part. So which is the first pair? Nathan.
Yes, so the pair is OTR and P, and then the correlation coefficient is 0.76.
0.76. That is correct. That's the first one. Second most multicollinear pair. Esther.
Please, it's C and then P with a figure of negative 0.74.
Very good. So this one here, negative 0.74. Let's add a third one. The third most multicollinear pair. Who can guess that? McDonald, welcome to the club.
Okay, so LU and P, which is negative 0.62.
Wrong. Let's go to Genevieve. Sandra Foy.
So that would be M and C, 0.71.
That's wrong. So this means that you have to always look hard. Don't just skim through. You got to go through left, right to the end. Otherwise, you will be making the same mistakes in the exam. Priscilla.
Please, that would be 73. M and RM with the coefficient of negative 73. 0.73.
So that is a correct one. Okay, so that is a correct one. So guys, learn how it works here. Now the last one here, what about the least multicollinear? The first, second, and the third least multicollinear. Least multicollinear. You can give me the first one. The first least multicollinear. Emmanuel.
So M and OT with correlation coefficient of negative 0.03.
Okay. That is correct. Second one. If you don't know, yours is to be writing these things. What is the second pair? Joseph.
Joseph, you have an eagle eye.
That's RC and OT with 0.05.
0.05. That is correct. Third one. The last one. Third pair. Esther.
That will be LU and C, 0.14.
Correct. It's good you didn't say negative 0.11. Okay. Because that was not multicollinear. That is collinear. That is correlated, highly correlated, least correlated, but it's not least multicollinear. So take note. Very good. So you should master this correlation thing a lot. Now, let's go back to the Excel. You can also generate a regression with the Excel. So we've done summary statistics, we've done correlation, okay, which is this, and now we are going to do in Excel the last one, which is regression. Now to do the regression, let's go to the Brukutu data set. So if you check all these things, we are using the Brukutu coded. Okay, once again, you click on the data tab, like we've always been doing. So you are not going to you're not going to use any other data. You're going to still click on the data tab. Okay. Click on the data tab and then click on the far right data analysis. And this time scroll to the down, you see regression and double click on that. Okay. Now the thing about a regression in Excel is that you have the Y and then the X range. So for the Y range, the Y is your dependent variable. So you click on the dependent variable. And our dependent variable is a Q. So you go and click on Q and drag only the Q to the end. Okay, click the Q and drag it to the end into the Y range. Then when you finish, click inside the X range, input X range. And then the X's, they are all the others. So scroll up until you get to the X, and this time click the P, move it to the right till you get to the RM, and now drag all of them to the end. Okay, and be careful when you exceed, come back. That will also collect the S range in the box. Tick labels in the first row, and where do you have the new worksheet, type reg for regression. Reg for regression. And when you're done, click enter or OK. It will create a new sheet, and that new sheet is known as regression. We'll talk about this very one next week, but rather using the R version. So this is a regression. There are 13 questions that you'll be asked about this in the exam, and we shall do all of that next week. But for now, let's go back to the, yes, Emmanuel.
Prof, thank you very much. So I would like to find out, in a situation where you have two independent variables, how do you go about it in the regression?
When you say how do you go about it in terms of what?
So for instance, independent variable, yes. So for instance, you selected Q, and then when you opened there, you went to the regression dropout. You selected Q at the, so let me, okay, so data analysis, regression. So at the wide range, so you selected Q here. So what I want to find out is that what if you have two independent variables?
But the Q is not an independent variable. Q is a dependent variable.
Oh, sorry. When you have two dependent variables.
You will not get two dependent variables unless you are estimating a logistic regression, which you are not doing this semester.
Okay.
The dependent variable is always one.
Okay. All right.
Yeah. But if you are estimating a logistic regression, you will not use Excel. You will use R for that.
Oh, okay.
Yeah.
All right.
And we're about to use the R right now, so no problem. Okay. So now let's open our R Studio. For those of you who have not opened your R Studio, open your R Studio because you're going to continue the same thing in the R Studio. And I'm going to use a new sheet. Okay. So if you check my distance, this is I'm going to open a blank script. So click on the plus symbol here and choose R script. So you see an empty sheet like this in the command window. I'm going to use this one. And I'll be toggling between this and then the Excel, the slide. So when you go to the slide here, you notice that the first thing in the slide is this command. You are going to copy the blue commands or type it. But you can't type it because I'll be moving a bit faster. But just copy the blue command if you can, or just type and follow me. We are going to copy this first command to load the data, this one. Okay, we go to the R Studio. And then when we get to the R Studio here, you just Control V to paste the command. Watch the command. The command says gin equals to read.delem equals into bracket clipboard. I'm sure we did the same thing when we're doing the ANOVA, if you can remember. So this command will help you to load the data from Excel into R. From Excel into R. So now go and copy your data in Excel. Let's go to the Excel. Now, this is Excel, but you will not use the coded data. Remember, we are going to use a Brukutu data, this one, because R is sensible and it can recognize categorical variables even without one hot encoding. So as you can see, they are not 0, 1. They are just normal urban, rural, urban, rural, and things like that. R will understand. So just copy everything here. You can click inside here and do Control A to highlight, Control C to copy. And once you've done that, I'm going to really reward some people by the end of this because this is tough exercise. So by the time you do this copy, go to your R Studio. Here in your R Studio, don't paste all. Whilst your cursor is blinking in number 1, just click on the Run. Click on the Run. Okay. You click on the Run here like I just did. And you see your data name written blue in the console, just as it was in the command. When you see that blue thing down there in the console, it means that your data has been loaded beautifully into the R. Okay, you're done. Now, the moment that happened, you see that cursor has gone to number 2. Okay. By the way, you can show the data. You can show the data to be sure that it's been loaded by highlighting only the GIN. Remember, the GIN is the name of the gene that we gave. Just call it gene. You can use anything, any letter. But let's use the gene for uniformity. Now, once you highlight it, run it again by clicking the Run. And you see that the data is now showing nicely down there in the console, as you can see here, with all their names nicely. Who has been able to do that? Raise your hand and let me see. Whoa, that's really good. Quite an impressive. I thought I was going to see just 2 hands. Wow, that's good. Let's move on. This is great. So go to the note as well. Now in the note, you will see summary gene. Okay, just copy the summary gene and then go to your R Studio again and paste that in number 2. That will give you a summary of your data set. You can run it again and you see a summary of your information. I'm not too keen on that because summary status, and you see that this same summary is the same summary you got in when you did the Excel one. So let me just give you one tip. For example, the price of gin is a P. Okay, the mean tells you that the average price of gin is 15.10 cedis. That is the average price of a gin. Now you can see that location didn't have summary statistics. It only had the length. Occupation didn't have summary statistics. It only had the length. The same thing with religion. Who can tell me why? Who can tell me why? Well, it's because they are categorical variables. R is sensible to know that you don't need to find the mean of gender. You don't need to find the median of location. Whether it's urban or rural, you don't need to find because these are dummies. Okay, let's go back to the slides. The next thing you are going to do, yes, Prince.
Yes, Doc. So, with reference to the slides you are making, I'm just checking if it has been shared with the class already.
Ask your colleagues. Can somebody answer him?
Might have missed it, but seeing it's not on Sakai at the moment.
Can one of you answer him for me?
Form.
Do you all have the slides?
No, Prof.
Nobody has a slide.
It's way back. I'll reshare it, Prof.
I gave you the slide the day that we met, the first meeting. Then I sent you the slide right after that. But because you ignored and didn't see importance of it, you did not look at it. And today, you can see clearly that you need it. Okay. Now, the next command will require you to install this package first. Okay. So this package is called psych. You go to this thing and type this package. But before you can install it, you see, you write requires psych. Before you can install it at packages. When you come and click packages here, okay. Then after clicking packages, you click install. A pop-up will come. Then you type psych, PSYCH. Now, I have already installed it, but you have to click install, and if you have an internet, you can install it. But I have already installed it, so I will just run it. But you would have to install it first before, when it finishes installing, then you can run. So let me run my psych. I just did the running of the psych. And then after that, you're going to type describe into brackets gin. So that is going to give you a proper description of the data set. A proper description of the data. Now, when you run this, you get something. This is what you get. It's a beautiful descriptive statistics, more than the first one. The first one, which is summary statistics, this one gives you more. And there is something that you notice in the results down here. You will notice that it has added more variables. Apart from the mean, the standard deviation, you have the trimmed mean, the minimum absolute deviation, maximum absolute deviation. Okay, you have the minimum value, maximum value, range, skewness, ketosis, standard error, and so many. But then at the last three, you will see that it has starred them. Star the last three. Who can tell me why it has starred them? Why is there a star? Why is there a star for the location, occupation, and religion? Yes, nighttime.
They are categorical variables.
That's it. You should know this thing. Okay. So what it means is that you shouldn't focus too much on their descriptive statistics it's provided because they are not that meaningful. So you can see that describe gives you more information than summary. That's all I want to prove. Okay. Now you can also do a describe of some specific thing. You can even create a contingency table. Let's go to the slide here. You can run this one and create a contingency table. Okay. You can create a contingency table. You can copy this, go to that, the RStudio, and paste. And watch what you are seeing here. You see that when you run this table, and this is what you're going to get. Look at what I'm getting. You see, it will give you a contingency table of all the necessary information. So watch. You have the location and then location urban and rural. And on that location rural, you have how many shops are Buddhist, Christians, and Muslims. And for Buddhists, how many are fishing, teaching, and trading? So let me ask you some tricky questions. This is called a contingency table, by the way. You'll get something like this in an exam too. A contingency table. It gives you an assessment of the categorical variables. It categorizes the categorical variables. So when you look at rural, how many Buddhists are in the rural area? Who can tell? Looking at the numbers, how many Buddhists are in the rural area? How many Buddhists are there? How many Buddhists are in the rural area? Yes, Eunice.
8.
8, correct. And how many Christians are in the urban area? Felix.
12.
It is 12. It is 12. Now, how many teachers are in this company in general? How many teachers are there in all? Emmanuel?
12.
12. By the way, those of you who couldn't see the 12, the teachers need to count this 4 and this other 2 different 4s. Okay, so you look at the teachers column and you'll be able to know, okay, how many teachers and how many fishers are in the urban area. How many fishers are in the urban area? Genetrics.
12.
Okay, so you're getting it. So contingency table, you will have a contingency table similar to this. Remember that the one you have will be more than this. Plenty categorization. And you should be able to make sense of all of these. Yes, Priscilla.
So I have a question. Is it possible that you could have someone teaching and at the same time trading?
No.
So that
No, not in this data set. Okay.
Okay, thank you.
So you can do a contingency table like you have just seen. Okay. And another thing you can do, you can also describe by, let me show you here. There are so many things that you can do here. I'm only picking the important ones. You can do a histogram of some of the variables. Okay. I'm going to create a graph. Okay. And this graph, you can copy this and do it with me. This graph is a kind of a legend that you are telling R that I'm about to create some graph, but I don't want you to do them one by one. I want you to combine the next 4 graphs together. So this 2 by 2 means that the next 4 graphs should be positioned 2 by 2. If you make it 3 by 3, it means that the next 9 graphs should all be on the same page. So, but I want to just do 2 by 2. So the next 4 graphs, 2 here, 2 here, is going to be. So you run that first. And after you run that, pick the next graph. The next graph is a histogram of quantity demanded. A histogram of quantity demanded. Let's run the histogram of quantity demanded here. Okay. We copy that, and then let's do a histogram of quantity demanded by putting this one down. I wrote haste, kill, comma, the color is yellow, and I'm going to run that. Look on the fire plot area. The plot area is here. This is where the plot is. That's where the result is going to show. So let's run that. Oh, it says kill is not found. So to do the kill, just bring $G in front of it. So that it will show. Bring $G in front of it like this before the kill. And then run it. So now you can see that the histogram of the kill is showing. Okay. We can also do another graph. Let's plot the density of price. So type plot, then do into bracket density, then bring bracket P for price. Okay. Now, if the price might not work, so bring $G in front of it. Just as I did for kill, bring $G in front of the price and run it. So you can see the price, you have also gotten a kernel density plot of the price. And then you can also do, please just try to understand the meaning of histogram, density, and all of that by yourself. It's very, very simple. Okay. Both of them are similar, just that the density gives you a smooth graph. It tells you the distribution, how the data is distributed. Another graph you can draw, this one is quite long, so I have to copy it. I won't type it. Okay. And that is, you can see it in the slide there. That is the quantile normal probability plot. I'm doing it for kill. The quantile normal probability plot. Now the kill has gotten, you should bring the dollar in front of it as well. Just as I've always been saying, $G. Bring the $G. Wherever you see the kill and P, bring the $G. And so I'm going to run this. And to go to the next column, the next section of the graph, as you can see here. So that one has come down here. Quantile normal probability plot is a very good plot. When the blues are all seated on the red nicely, then it means that the kill is normally distributed. That's what it means. When the blues are beautifully seated on the line, the red line, it means that that variable, which is kill, is normal. Is normal. Write that down. You will need it one day. It's normal. And you can see that all my graphs are happening in the 2 by 2 area I defined. Okay. There is a final plot I want to copy. I want to copy and then show you. So in the slide here, I'm going to copy this final plot, a box plot. And I'm doing a box plot of occupation, of quantity demanded across occupation. Okay. So I'm copying that here. So watch it. The quantity demanded, it should bring $G in front of it, like we've been doing. The occupation to bring $G in front of it. So I'm going to generate a quantity demanded across the 3 different occupations. Remember, occupations are teaching, fishing, and trading. I'm going to run this. And you can see here, they are all showing here. Teaching, fishing, and trading. You don't see the fishing, the teacher hand. Now you can see it all. When you click and drag this left and right, you can see it all. So just looking at this box plot, look at the box plot. And like I said, each of these graphs, try and understand them. You can just ask ChatGPT to just summarize on each one for you. If you look at the box plot, you will notice that the black line inside each box is called what? Who knows? The black line, Emmanuel.
Please, is the mean?
It is the median.
Oh, sorry, median.
Okay, so the black line, just write it down, guys. The black line is called the median. I don't even have to tell you to write down. I mean, anything that is mentioned here you don't know, you write it down with the intention of just searching for it. So the black line is a median. So looking at this occupation, which one would you say has got the highest median for acquisition? Which of them would you say has got the highest median for gin? Looking at this occupation, which of them, Genevieve?
Fishing.
It is fishing. And this agrees with our assumption that we had before. So these are some preliminary information that you can do about this whole thing. You can even test whether the variable is normally distributed or whether it is not normally distributed. You can do a polygon of the quantity demanded. In fact, you can look at a polygon of the quantity demanded. That will give you some nice graphs, okay? I mean, you have all of them in the slide, so just go through them yourself. I just did a polygon, but that is not showing. Okay, why that is not showing? Let me just go and run this again and see. Okay, but the polygon wasn't showing. So you did a polygon, and then you can do several other graphs. I mean, just go and fidget with the rest. Okay, I'm done with that. But I'm also going to generate for you guys here a correlation that we did in Excel. We want to do it in R. Okay, so when you go to your slide, you see that there's something here called correlation. And correlation, R is sensible. It doesn't want to do correlation for the dummy variables. Okay, remember that in Excel, we coded them 1, 1, 0, 1, 0, 1, 0, 1, 0, and so it accepted it. But then here, it knows that they are not that important. So when you do a correlation here, this one, you can use it to generate a correlation and remove the categorical variables. Now, some people, they started this lecture and then along the line, because they are finding it hard or something, they left the Zoom. Tell them, I'm taking pictures of attendance. I've been doing that every 15 minutes. So let them know that it is important that they stay till the end. Okay, so I'm going to just generate a correlation. Okay, and look at the down there. This one, it will remove all the categorical variables. I mean, you have it so you can see. This is showing down here. So look at it. This is for quantity, for price, for complement price and income. Just as we did in Excel, we have it all here. We have it all here. Okay. It has removed the categorical variables because, and this was a question I've asked you already. Why do you have to remove the categorical variables when you're undertaking a correlation? Because the categorical variables will have a 0, 1. So 0, 1 will show the perfect maximum and the perfect minimum. And because of that, you don't need it because it's not ranging. The thing is either 0 or 1. So it's all going to be at the bottom or all going to be at the top. So there's no need to generate a correlation matrix for categorical variables because it will not be a proper reflection of the relationship. That's the whole point. So that is why we don't do that's why you can see that this command, I've even excluded the categorical variables. Okay, but I don't want to talk about the correlation because we've already talked about them and gone through several exercises for them. Very cool. Yes, Simon.
Okay, so good evening. I want to find out why a lot of researchers and scientists prefer to use specific softwares for this analysis instead of using perhaps the Excel for doing the
All
analysis.
right. Very good question. The reason is very simple. Excel is not, it's a child. Don't put it that way. The world is advancing. I am an expert in artificial intelligence, and I will never use Excel for my work. I model the behavior of companies. Excel has not reached that level where it can model brains. I optimize. I model high density data, complex revolutionary data. I'm talking about having Netflix, watching 250 million movies in a month. I mean, the number of people who are watching movies, about 250 million people are watching movies. You want to model the behavior of that. Excel can do it. Advanced, packages can do it, like R, and R is free. So the life is complex. You see, the real life is complex life. Real life. For example, when you're looking at a car right in front of you, you can see another car coming on your left, isn't it? Isn't it in real life? Opele, are you with him? The one who has
Yes,
it.
please.
And so
Yeah.
because you can see a car on your left coming and a car ahead of you, in front of you also coming, your eye is looking at things in both left and forward way, in a perpendicular way. When you're watching a TV in front of you and somebody is coming on your left side, you will see the person. You will feel the person. You will feel the person. So life is multidimensional. And you need a software that can handle multidimensionality. Full stop. Not 2D, Excel. So that is it. We are dealing with complex situations in real life. Excel can do it. For example, this graph that I've just drawn right now, Excel can never do it. These beautiful graphs you are seeing here and putting all of them in one go, like Excel, the way you click so many things, it won't do it. It can't do it. Excel can't do any of these things beautifully. It can maybe do just the histogram one. But the others are complex, So that is it. And there are some more complex things that Excel cannot do. Opele, have I answered the question? Okay. Now let's go to the last but one thing for today. And that is regression. So we are going to do, yes, Prince.
Yes, look, sorry, my line went off immediately after I asked the question, but I'm trying to follow with the slides, and what we have, it appears there's a slight difference. Even from the heading, I see this is named research methods, or what we have is research methods sessions, sort of. There's some slight
No, the
difference.
all is mine. The session is yours. That's all. Mine has got slide pauses. It's got slide pauses. I pause. Okay, but yours, you see the way it's paused. So I don't want you to do the pause because if you print it out, you'll be having so many sheets.
Oh, okay. Ours is 312 pages, and I see yours is 392 pages.
Yeah, that's why I said I have pauses. So what you are seeing is not pages, it's pauses as well. It's taking each one. You see here, yours, if you check, when you move from one to the other, do you see pauses like this? See the way this one has pause and come?
Okay. Ours flows.
Exactly, that's what I mean.
Okay. Thank you, Doc.
All right, so let's go to this one here, this side, simple regression. We're going to do simple regression. Okay, that's all I'm going to do. I'm going to do simple regression. This part didn't show. So I'm going to show you. This part of mine didn't show, but I believe that yours showed. Yes, Fifi. Ask your question.
Yes, well, thank you for the opportunity. So I have a quick question. It's more like a follow-up stemming from the question my brother asked. With regards to a software like R, is it, I mean, now we are living in a world which values skills. So is it a software that can be studied as a standalone where companies are in demand for it? Or
Absolutely. I've trained a lot of companies, banking companies, National Petroleum Authority, population study census companies. I've trained people just on R. Just on R.
Oh, okay.
Yes. Sometimes it's tailored, sometimes it's general. I believe that every company should even know R or Python. Okay. And use it because it's able to do a lot of wonderful things.
Oh, okay. Because for me personally, this was my first encounter with the software. So that's why I'm asking.
It's supposed to be your first encounter because I brought it first into the department, into the whole school at the time. When I brought it, some lecturers didn't even know. They were saying that, what is it? What is it? Today it's been accepted. So I'm a champion of R, and it's used a lot in top companies. I've used it in McKinsey, JP Morgan, Chase, and so many. I mean, the world is advanced. That's all I'm saying. So if you can, so some companies, they want their staff to even know, so they learn it. And there's a course on R that I could not take you through the course. It's also a bit of the R is on my, I just purpose it. I just particularize it for this course.
Okay. All right then. Thank you very much, Prof.
Okay, so let's continue. So, where was I? I've forgotten where the thing was in book. Where were we? Okay, so let's come to the data information here. Watch this. I've entered twice. And you can see that I've given a title. Anytime you're writing a title and you don't want to write it as a code, bring a hash symbol. The title is Burkutu Venture. And I've labeled it as simple regression. The data has already been loaded. And because the data has already been loaded, you don't need this information here. Actually, you can attach. You can attach and detach later. Okay, the instruction, everything after the hash is an instruction that I've given you. Okay. The first thing I want us to do, pay attention here, is that we are going to run the gene simple. So, guys, if you can see the gene simple in your slide, run it. I mean, I think you should be able to see yours. Maybe mine I can't, but you should. Do you have the gene simple? So, this command here is called gene simple equals to LM, then the kill, P, and all of that. Okay. Now, if you are going to use this, you should attach the data set. Remember, the data set is gene. If I hold a gene, I can run the gene again, and you can see the gene down there. Attaching the gene means I don't need to do the gene dollar anytime you're typing. So I want to attach the data and then run it. You don't detach. When you have finished everything and you're closing your R, then you detach. Attaching means you fix the data permanently so that R doesn't worry about identifying the variables inside the data frame. So I'm going to run the plot, but before I run the plot, I want to run the simple regression. Now look at the simple regression. The simple regression is Q being a function of price. So what you're saying is that Q, quantity demanded of gene bitters, depends solely on price. And this command is using a linear model. LM means a linear model. The name of the data is gene. And this will summarize the result. Okay. Now, I can run this command first. Let me run it. You should also do it. And this is the results down here. Everything in the results is what you see here. We'll talk more about this next week. But I want to plot the regression line. So I now go back from 21, I go to 19 here, and then run the regression line. And you can see on the right here that this is the regression line. Now, what do you notice about the regression line? It's a regression of quantity demanded and price. Look at it. When you check the relationship between quantity demanded and price carefully, is it positive or negative? When you check the relationship, is it positive or negative? Look at the relationship. Genetics
Negative.
is negative. Now, come back to the results. Now, look at the results. The results is here. And you can see that P is this one. And look at the estimate. The estimate is the one here. So when you look at the estimated value for the price, is it negative or is positive? When you look at the estimated value of price, is it negative or is positive? And what is the value in the result? The estimated coefficient for price is what? It's negative. Negative 14.263. Okay. Negative 14.263. So you can see that clearly the graph is reflecting what the result is saying. So we expect the relationship to be negative. Now, this is only for simple regression. Okay. Only for simple regression. Guys, there are several other things you can do, and you can have some. So this is just 2D graph I've drawn. Just 2D graph. But you can also do some more graph, not just the 2D graph, but some more graphs. And they are in your work. You should try them. Let me try one of them for you to see. Okay. And again, the most important one we have done. So I'm going to load a package called RGL. You also have it. You can look at that later. RGL. Now, because I didn't give you guys assignments, that is why I'm doing this thing with you. So you should see this thing as your assignment so that at least you practice. You practice before you see. Of course, you will never use this in an exam, but then I'll use the R to generate the results for you. And then you would have to interpret them. So let's take this example. I'm loading this library, RGL. Okay. Of course, you would have to install it first. And I'm going to do a graph, not only between quantity demanded and price. I'm going to do a graph between quantity demanded price and complement price. Quantity demanded price and complement price. So look here. Look at this. I've written scatter 3D, kill, PC. So three things, kill, PC. I'm going to run this. The graph has come, but you don't see. Let me show you. Okay. It is a 3D graph that is here. This is it. If I click and drag it, you see that it is showing a 3D nature of the quantity demanded as a function of price and complement price. Do you see it moving? Do you see it moving, by the way?
Yeah.
Okay, now watch it.
Yes,
Now watch it. I can make it a 2D graph like this. You see here, it's just the relationship between price and quantity. So it become a line. Now, what regression is doing is this. Regression, so this is a data point. These are data points, okay? And regression is trying to minimize the line, the vertical line. If the line is above the black line, it is called positive error. If the line is below the purple line, it is called negative error, or the red line. It's called negative error. And some of the errors are positive, some are negative. What regression, ordinary least squares regression is doing is that it is minimizing the error sum of squares. It's minimizing the errors. You see, you are trying to establish a relationship between high blood pressure and weight. high blood pressure, and smoking status, high blood pressure, and other things. And any error, any unobserved error, you want to minimize it. So that's the idea, so that the error will not affect the relationship. And that's what regression is doing. So it will try, that's why the lines are showing the way they are. But this is a 2D graph, and 2D graph is easy. Okay. Now to make it 3D, now you bring complement price. So now the dependent variable is 1, kill, but now the independent variables are 2. You can use this graph to draw. Now it's no longer called a line because there are 3 of them. The moment there are 3, it's no longer a line, it becomes a surface. Can you imagine if there are 4? You don't even understand it. Okay. See the way the thing is. So if it's a surface, now it's looking like a polyhedra, and it's actually a polyhedra. And it goes on. If suppose there are 4 values, 5 values, then become mania. You can't even understand. So that's why normally we don't do these things. Because when we do many things, surfaces like that, it becomes a rhombus, a cuboid, a parallelogram, a complete hexagonal polyhedra. And you don't understand. So now we make it simple and we use a line, which is what you saw in the one that we did. We just use a line. That one becomes easier. You're able to understand. Everybody is happy. So this is just to let you know in your life, for once, that look, I saw a 3D graph of a regression line. One day you tell your children that, you tell your children that, you did something when you were doing your master's and it was something. Then you now can show that your master's that you did, it was not a toy. It was not a toy at all. In fact, there is another package you can install. And I like that package sometimes. There's another package you can install, and that package is known as this. It's called Library Scatterplot 3D. And that one, what it does is that that one will not move. Okay? It will not move, but you see the thing very clearly. So if you run this and run that, this is how it looks like. You see the whole thing looking like the data points are hanging in the box, as you can see right here. Very good. So next time we meet, this is what we are going to be doing. We are now going to estimate a multiple regression. And guys, before we end today, I'm going to estimate a multiple regression for you. And then next time we meet, we'll answer all the questions related to the multiple regression. These questions will be similar to the questions you would also have in your exams. Okay. Will be similar to the questions you will get in your exam. So I'm showing you something. Let's go to the slide. This is the command we are going to use to do the multiple regression. This one. Okay, I'm going to just collect this and then run the multiple regression with this. Just this. And watch the results you're about to see. Okay. So you can, like I said, you can take your time and run all of this one by one and be seeing the result. So watch this. Watch this. Watch this. So this is gene multi. Why I call it gene multi? You can call it even your name. So gene multi because we are doing multiple regression. And look at it. It says gene multi equals to linear model. Kill is dependent on price, complement price, income, location, occupation, religion. Everything has been brought to bear here. And then this will summarize the entire result. Let's run this. Now look here at the bottom in the console. You see everything in the console here? Your exam will have a result similar like this. And here, I will ask you 13 different questions. And we shall pick on these 13 different questions tomorrow, next week. Everything you see here, there is a question on each one of them. Please, I want you to go home and do everything and run this multiple regression so that you can see it yourself. By the way, who has been able to run this multiple regression? I know when I was going through, I know many of you paused along the line, but who has been able to run this? Nobody. I mean, I was expecting that, this is normally the one I used to catch people in the end. This one. When I say it, no, be praying, hey, let me do it quickly, and raise my hand and say that I did it. No. You should have been able to be following and run the multiple regression model. So what is a regression? A regression simply establishes the relationship between one dependent variable and multiple independent variables. That's it. But looking at the results here, what is the importance of price, complement price, income, location urban, occupation teaching, occupation trading? Why is it that we chose only location, but now occupation urban is showing? Why is it that we showed occupation and now occupation teaching, occupation trading is showing? What has happened to the reference category? Guys, let me share something with you about reference category before we end. Do you remember that we spoke about location, okay? And location was split into two levels. What was the first level? What was the first level? Rural, and the second level is urban. So if in the story here, you see urban has been written, it means rural has been made the reference category. A reference category is the one that is not written, but it is, the other one is mentioned always in reference to. So here, anytime I mention urban here, anytime I mention urban, I'm talking about urban in relation to rural. Now, when you look at the occupation, teaching has been brought. Occupation trading has been brought. So which one do you think is a reference category for occupation?
Fishing.
Exactly. Which one do you think is a reference category for religion?
Buddhist.
Buddhist. So you should know that the reference category is the one that is not there, but anytime you mention Christian, it is Christian related to religion, Buddhist. Anytime you mention Muslim, it's Muslim related to Buddhist. So the reference category is behind the scene hidden, and it is the one that is a reference category. Next time we meet, you're going to understand everything about this regression. Ladies and gentlemen, that brings us to the end of the entire caboodle.